Great. So my name is Ernesto. I'm from OpenZeppelin. I'm coming from Mexico here just to give a talk about how to use OpenZeppelin Defender. Basically, this is an example of a very specific use case that you can use within OpenZeppelin Defender. OpenZeppelin Defender, as Mike stated, is one of our tools that we have at OpenZeppelin. And basically, you can wire many of our components to create these sort of use cases. So I'm basically going to walk you through this. And yeah, here's some questions for you on whatever you have to say. OK, so Mike already went through this, but basically OpenZeppelin is a cybersecurity firm. We do audits and many other stuff. You already know about our products. I'm going to focus on Defender, which is like our AWS sort of thing to manage transactions and many other fancy stuff that you can do over there. So before we start, I'm going to give you a QR so you can go to a meetup that we are going to have like late in the night. So yeah, just scan it and see you there. I see some people scanning. Great. OK, cool. So I'm going to continue. Cool. So I'm going to start with this thing with the ENS. Does anybody knows what the ENS is? If not, I want to talk to you about this. But it's basically the Ethereum name service. They recently became a DAO, and they did an airdrop. So basically, the airdrop was a thing in which they distributed their tokens to the community. And it ended up being a really fair distribution. As you can see, there are some people with the most voting power is like 0.36%, which is not really that much. So the thing is, there are many people with voting power, and you can delegate your tokens to somebody so they can vote on your own. The actual distribution is that you can see the guy with the highest amount, it's not the majority, but the highest amount of voting power is Brantley, is the director of operations at the ENS. And things were doing good until this happened. I'm not going to say anything about this. I don't have any opinion. But regardless of the situation within this, the thing is that many people started to comply. So we saw many people on Twitter trying to redelegate and basically remove voting power from Brantley. So after this, Nick Johnson, which is one of the engineers in the ENS, one of the lead engineers, said that we can basically set up a way to redelegate their tokens, the people tokens, by setting up some things that I'm going to explain later. But yeah, basically using this delegate with SIG function, which is in the governor contract that the ENS DAO is using. This is a function that we have in OpenZeppelin contracts. Actually, the ENS was built using OpenZeppelin contracts, which is great. So I'm going to explain exactly how this works, because this is how it was actually done. The ENS DAO subsidized 10 ethers just to redelegations and free redelegations for everybody who has above 100 tokens, so they can basically redelegate by free. OK, so how does the ENS token work? It's basically a token, an ERC20 implementation using OpenZeppelin contracts. And also, if you're a user and you are like a user who can claim the tokens, you have to put a delegate in the claim function, which you are selecting when you're claiming the tokens. This is basically a way in which you can let the governor to be like represented by a delegate, so you don't have to worry about voting and any of that stuff. So when a delegate is going to vote, he just calls cast vote, and basically the smart contract calculates how many power he has and submit the vote to the proposal. OK, so the thing is that after all of this, as I said, Brantley was the guy with the most voting power. So this is the delegate by SIG function. As you can see, there is a delegate function in which you can change who is your delegate. And there is also a delegate by SIG who is receiving a signature from a user. So basically, anybody can submit a transaction in behalf of another user who signed a message. This message is used to validate that the actual signature is true, and then call the delegate function. So in order to do this, we are using the EIP 712, not 721. That's for NFTs. 712 is for structured data signatures. And the problem basically is this one. If you are going to assign a message, which is like a normal message, this message is not suitable for like executing functions or whatever you want. So that's why we have this like shape of data that you can use in order to sign structured data. Basically, it is a way in which you use your wallet to sign some sort of message that is structured in a specific way. So for this particular case, this is the workflow. First, you as a user sign a message with the domain separator and blah, 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 some technical things regarding to the call of the delegate by sig function. Then your wallet returns just your signature, and then you use that signature to give it to some subsidizer, and the subsidizer can post or call the delegate by sig function using the signature that you use. In this way, somebody can pay for your delegation without you worrying about gas prices or whatever. So we decided to, well, the ENS decided to use this. This is how structured data signing looks like in your MetaMask. And this is what actually happened. Nick Johnson announced that there were a lot of redelegation for subsidizing. And yeah, so now I'm going to go to the Defender part. The thing is that it is theoretically possible to set this up, but the thing is, how can I automate this process without worrying about receiving signatures and then posting like on demand? So the thing is, we are using Defender, and we're using basically two of the services that we have. The first one is Relayer, which is a private key management that we have on Defender, so you can set it up to manage transactions in an automatic way. And yeah, that's basically what it is. And also Autotask, which is basically a Lambda function that you can wire to an Autotask, and also you can wire to a Relayer. And basically, within the Autotask, you can call the Relayer to send transactions. So this is the way we're going to like set this up. And this is the complete workflow. It's basically a standard version of what I already shown you. And it is basically, OK, you have a UI, and user goes to this UI, use their wallet to send the message, and we send that, that structured data message to send it to the Autotask. The Autotask posts it to the Relayer. Some subsidizer puts some Ether to the Relayer in order to pay for gas. And then we use the Relayer to actually call the contract with the delegate by sig function. So here's the demo. You can copy the link if you want. I'm going to try to go through it. Let me see how many times that I have. OK, I think we're good. Cool. So this is basically how the project looks like. It is a very simple UI in which you can read how many tokens you have, who have you delegated to. Then you use your wallet to put another address and then redelegate your tokens. So that being said, I'm going to move to the actual repo. The repo is fairly well documented if you want to try it out. There are some instructions here regarding how you can set this up. So the idea is basically, first, we have to deploy a token, an equivalent token, similar to the token that the ENS is using. This one is under the folder hard hat and contracts, and this is a contract. As you can see, we're using the OpenZeppelin contracts. Basically, let me do some zoom here. OK, so basically, we're using the ERC20 bows, which is the one that has the delegate by sig function. We're inheriting from it, and also, of course, warning, this is not suitable for production. Please don't use it. It's just a demo. OK, so I'm going to clone this. So I'm going to open my terminal, do some zoom over there. Hello. Is everybody seeing it, right? OK, cool. So I'm going to clone this into a Portland demo 2, because I already did 1. Great. So I'm going to enter into Portland demo code. Yeah, I trust myself. Cool. So this is the code. I'm basically going to go to the hard hat, and there is a README here, which is telling me to use some environmental variables that I need. There is an example file here. Basically, you will need an Infura account. Infura is a provider for JSON RPC's APIs. Also, we have a private key that I already have. Yeah, this is not obviously a real account. Also, a Etherscan API key. You can request an Etherscan API key. This is just for verification purposes, so we can claim our tokens from the Etherscan UI. So great, let me just open my notes. And I'm going to use this one, create a .m file, and copy this. Great. So following with the instructions, I'm going to need to obviously select my network of preference. I'm going to use go early because it's the one who has the faucet, who's the majority of the time available. Also, I already funded my account. You probably should fund your account in case you haven't done it. And finally, just run yarn deploy. Let's see if everything goes really well. Yeah, of course, I have to do a yarn inside the hard hat. And there we are. And let's see, because everything breaks in a demo, right? OK, compile successfully. Let's just wait until it's deployed. Weird moment. OK, in the meantime, I'm also going to explore what OpenZeppelin Defender is, because we have to set up, no, this is Defender, that OpenZeppelin. We have to set up an account that we are going to use to create a relayer and also an Autotask. Great. I think it's waiting. Cool. So we can go to the relayer section. As you can see, I have two relayers here. I'm going to create a new one, which is like Portland demo number 2. This is on Go Early because I'm deploying my token on the Go Early network. I'm going to do create and just wait. Since OpenZeppelin Relayer is not exposing the actual private keys, I mean, not even us have access to it, you can always copy an API key to send transactions using the API key. So this is very handy because if you lose the private key, there's nothing to do about it. But if you lose a private key, you can just delete it and create another one, which is great. I'm not going to use this, so I'm just going to go to the relayer. This is already it. As you can see, I have already one it because we already found every relayer on testnet. Cool. Let's see if this has already. Wait, it hasn't. OK, if it doesn't work, I have another one deployed because of another demo that I did. But let's just wait to see what happened. OK, so step number 2 should be claiming some tokens, which I cannot because it is not deployed yet, and follow the Autotask creation guide that I have right here. One of the great things with OpenZeppelin Defender is that you can set up and create your Autotask via API. So for example, you can have a repo with your code there and basically upload and update your Autotask from the terminal or for whatever you're using to do your workflow. So I have my code here. This is basically what an Autotask looks like. It is basically a function. As you can see, it is pretty similar to what AWS Lambda is. But we can inject some API tokens and keys, so you can use our services, like, for example, the relayer. And you can use this as a signer that you can wire to a contract, so you can basically send transactions to the contract in behalf of the signer that is an OpenZeppelin relayer. OK, so here it is our call to the delegate by sig function using the parameters of a signature. And yeah, for some reason, this is not deploying. Let me try it again. If not, I'm going to use another contract that I have. Let me just open the other demo. OK, this is new. Let me go to this one. It's pretty much the same. It's just that I already played with this one. But here you have, it's the same configuration. And let's suppose that the ENS token was correctly deployed. And let's move to the front end because I have the token address here. OK, so this is the deployed token. basically, it is a contract. As I said, it is already verified, so anybody can come here and just go to write contract and claim some tokens. I already claimed some just for the demo that I did a few minutes before. But yeah, you can basically claim your tokens just to play with. Cool. So next step is going to be the Autotask. The Autotask has a script, which is a create Autotask script. So basically, the script is just posting the code of the Autotask to our client in Defender, creating the Autotask in the actual UI. So I'm going to do this right now. Let me just move to the Autotask folder, and I'm going to do yarn create Autotask. Let's wait for a minute. And there it is. I have a URL here. So if I move to OpenZeppelin Defender, there it is. As you can see, we have a webhook URI that we can use to basically call our function or whatever. So I'm going to use this one, and I'm going to copy it into the front end, which is here, replacing this one. And of course, I'm going to move to the front end. And it should be opening in localhost 3000. OK, so this is basically the UI. As you can see, it is a pretty simple UI. You can connect your wallet, which is what I'm going to do. Let me just connect my MetaMask and move to Go Early, which is the one that I'm using. OK. And there you have. In this account, I don't have any tokens, probably in the account 4. Yeah, as you can see, I have 150 tokens, which is something that I already claimed from my contract that I deployed before. And here's my current delegate. It's a random address that I said before. So the idea is basically to change it. Let me just move something in the code, because since I already did it, the nonce, where it is. OK. The nonce, I think, should be number 2, because I already did twice. This is how the sign typed data looks like. It is not signing a message, it's signing an actual data structure. So I'm just going to change the nonce, because, yes, I already did it before. OK, let's see if this is working. I'm going to select another different account, let's say number 5. And I'm going to put it right here, click on delegate. And this is what the structured data message pop-up looks like. It's basically like a signature request with some data here, like, for example, the delegate, the nonce that I'm using, and when this signature expires. I'm going to sign it. Let's just wait. And if I'm going to OpenZeppelin Defender, here's the run, as you can see. And let's wait for it. Tense moment. Please. There it is. OK, it worked. And as you can see in the UI, I can see the transaction. But actually, my new delegate, as you can see, was updated to the one that I use. I didn't pay for any gas. I didn't basically have any Ether in the account, I guess. So this is how it works. Basically, you can set it up for anyone else to pay for users' transactions using this scheme and using OpenZeppelin Defender in an automated way. So that's basically the demo. Let me just get back to here. And just to wrap up, one pro tip is that probably you are worried about the funds that you are setting up in your layer. What if the gas prices goes crazy and went to, like, I don't know, like 1,000 GWh per gas? You can set it up a gas price cap that we have on Defender. So basically, every transaction that you send never passes some threshold that you set. This is actually what the ENS Foundation did. Set it up to 100 GWh per gas, and that's how it worked. Some things to consider. There is a griefing attack that can happen if you leave your Autotask open to anybody. Somebody can abuse it, obviously. So one way to avoid this is like setting up, for example, the nonce to 0, so people can use it just once per account. Another way to protect it is like, I don't know, adding extra values to the signature or do something else on the actual Autotask code. What if you want to do broader meta transactions? Well, probably you will need some extra and more complicated setup, which is setting up forwarder, which is not needed in this case because we are using a signature to basically call the delegate function in your behalf. But there are some functions that you cannot call with a signature. It depends on the contract implementations. So for these cases, you can do it, but you need a forwarder. And there is a YouTube video from Santiago Palladino, which is one of the lead engineers in OpenZeppelin. You can copy this URL if you want to try it out. But it is basically the same principle. And yeah, finally, we are hiring. We have positions for blockchain security engineer and full stack team developer, as I am, and many other things. Also, remember, this is the QR code for the meetup that we are going to have. And thank you very much. Follow me on Twitter, and I'm going to hear some questions from you. That's it. No questions? OK, thank you very much. It was a pleasure to be here. I wish you to be successful on the hackathon. And thank you very much. I'm going to be around here if you need some help with Defender or whatever.